Hi, this is CaitlinHerington's Mind Map for Psychology 4111. I'm going to start by talking about the biological building blocks and the primary motor cortex, which is in control of the complex voluntary movements. So not involuntary ones like breathing or your heart beating, but the voluntary ones, and the somatosensory cortex, which takes in multiple sensory information from stimuli and integrates them into sensory and motor output for use by the person. I think the nature-nurture debate is really interesting about the difference between the influence of genetics and the influence of the environment on humans, particularly those with ADHD, which is what I'm very interested in, and autism and the other kinds of neurodivergences. Epigenetics is a really interesting study of that process about which one is more important, but epigenetics is focused on the environmental influences. Whereas we are starting to believe that genes have a much stronger impact on the transmission of ADHD, for example, has a high rate of heritability, that if parents have it, children will have it. So the genotype is present in people. It is the building blocks. The autosomal chromosomes come in pairs of 22, plus then you've got the individual gender markers from each parent. The genotype, you can have something present without actually having it expressed on the outside. And the classic example is something like red hair, which takes two recessive genes to become dominant and be expressed in the phenotype. Whereas you can have a genotype of red hair, but because you've got a dominant blonde gene, you don't actually wind up having red hair, you have blonde hair. The karyotype is a very interesting thing that's an image of one person's whole chromosomal array. So, neurons and neuronal communication are really important for psychologists in terms of the way that chemical messages, chemical signals are converted from electrical signals that are sensed into chemical signals that are managed in the brain at the axon terminals. So where the synapses meet, and there's a synaptic cleft, a gap between them, which is filled with chemicals. And up until that point, it's electrical, and then it becomes chemical. So neurotransmitters and neuromodulators are really important. Some of them affect the way the brain works. The neuromodulators, they modulate, but neurotransmitters have two states. They can either convert those messages into an action potential, convert it into something happening, or they can inhibit that and reduce that. So I was very interested in the role of psychoactive drugs in this process, particularly agonists and antagonists, because they're used often for things like ADHD. So, for example, Ritalin. And this diagram shows how Ritalin affects all the various parts of the body when you take it. It's a stimulant, so it increases the amount of dopamine and noradrenaline in the tiny gaps in the synapses and block the transporters of dopamine and prevent their reuptake into the body. So, week 3, we were looking at sensation and perception. So, we followed that process much more about reception and sensory coding and transduction and transmission of these signals, how they are received through the sense organs as stimulus. Sound, smells, light. They are coded into electrochemical signals and changed to a form, transducted into a form that can be sent to the brain, and transmission where they are sorted and processed in the brain. So there's two kinds of processing. There's top down and bottom up. And as shown with this picture, could be a rabbit, could be a duck. Top down processing is the combination of your perception and your cognition, so your cognitive abilities, whereas bottom up processing is generally quite much faster and much more immediate, and it's just the reception of the stimuli that are perceived immediately. The sensations are taken in and an understanding is formed. It might not be a correct understanding, and top down is when you find that middle ground between the two places. So perceptual sets are really common when you're thinking about bottom-up processing, because we immediately jump to certain conclusions about what things are. And perceptual constancy is that top-down processing when we understand that a door is still a door, an elephant is still an elephant, even if we're seeing it from the wrong angle or a different angle that we're not used to. So the five sensory systems are really obvious, and I was fascinated by which parts of the brain they connected to and how many of them connected to that somatosensory cortex that actually seems to take in and manage so much information from outside. There's a really interesting theory about ESP is being, particularly with ADHD kids who have quite a lot of ESP in some ways, that their reception of a stimuli and their ability to process that occurs below the threshold of perception. And so they know things that they don't know they know. They just walk in and go, oh, this room has a bad vibe. But in fact, their brains are processing a whole lot of information that we're not seeing in a hurry. So week 4 was learning and behavior, and a lot of animal experimentation that went on in the early days, reflex about the relationship between reflex and instinct. Is it just, oh, that's hot, I don't want to touch it? Or is it, oh no, I'm having a baby, I feel like I need to nest now, which I've been through. You get these urges that you don't know where they come from. So it's about these biologically pre-programmed states. But reflexes are reactions to stimuli. They're quite immediate, they're very direct, whereas instinct is more complex and it involves behavioral processes. But it doesn't quite rise, neither of them quite rise to the level of learning, because learning is an adaptive process that about retaining that information and processing it for the future. So if we get habituated to a stimulus, we start ignoring it. We're not threatened by it, so we zone it out. If we're sensitized, we are waiting for it to happen and predicting that it will occur again, and so we're reacting badly when we see it. And there were basically two kinds of associative learning. Classical conditioning, which was the earlier stuff with Pavlov and his dogs and his bells and his saliva and all that stuff, which was really interesting, that there were shapers. They were shaping these reactions through natural reinforcement. So food creates saliva, it's a natural relationship, and through neutral and unnatural secondary reinforcers like the sound of a bell, which you wouldn't normally expect to make somebody or something drool, but they do. So the bell was a conditioned stimulus that Pavlov introduced to the dogs, and the food was an unconditioned stimulus where they would normally have that reaction to food. Whereas operant conditioning is much more complex than classical, and it involves the acquisition, the extinction, and the spontaneous recovery of learned behavior. But it also, they added in these layers of, is it a negative stimulus or a positive stimulus? So with the bell, it was kind of neutral. It was a sound. It didn't do anything. Whereas the operant conditioning people added in this idea that you could have negative and positive reactions to things, and that the timing of the reinforcement actually made a difference. But I really love, these rats are proving everybody wrong, because they've given them little cars to drive, and they will drive the car even without food as a reward. And sometimes they'll even choose to drive the cars because they're fun. There's no benefit to the rat other than entertainment. And they will choose to drive the car over food, and over treat food, not just any food, but over special food. So cognitive learning is really important. As a process, particularly for teachers, that you've got latent learning, insight learning, and observational learning. And all of those states have been observed in animals. That some is accidental, very operant. I push the button until the thing happens and I get the food, and after a while I start to associate the food with pushing the button or the lever. The insight learning, where you leave me alone and I think about it, and particularly they found this with chimpanzees, that once they thought about it for a while, then they knew what they were doing and they went and got the food. And observational learning, where you're patterning and you're modeling someone else's behavior. You're seeing someone else do it and then you're copying. I'm not that fond of behaviorists being a teacher, and I find Adler's generations of children and suicidal grandchildren suggests that some of this isn't directly transferable to humans. But anyway, in week 5, we talked more about memory. And memory is really important when talking about psychology, because to repair something that might be considered to be broken or mismanaged, we need to be able to understand with the memories and the patterns that underline those things. So schema are ways that we organize our memories, and they can be false. They can be incomplete, they can be mistaken, and they can be fed false information. So the idea of memory coming from fractional seconds of stimulus, the sensory memory, which is that the slugs, which responded badly and positively to various kinds of treatment. It's really interesting that short-term memory is based on that short-term memory comes from our perception and senses, and all these layers and layers of complex memories, whether they're explicit or implicit, whether they're factual and narrative and visuals, or whether they're more habit-based and action-based, as the implicit ones are. There's a pattern of activity that comes with an implicit memory, whereas an explicit memory tends to be more of a narrative held in the head. But either way, they're quite interdependent, and the long-term memory goes around and comes back from short-term memory, and things come in as short-term memories. They're managed with the working memory, they're manipulated and processed, and sometimes they're used and spat out again. And sometimes you get this process where the short-term memories become long-term memories. And when we're dealing with trauma, we have to ask ourselves how and why this is happening. So there's encoding, the data entry stage, and I'm using computer metaphors here. There's the data entry stage where the data is taken in from the stimulus, it's perceived. Then there's the storage, the retention of those electrical currents and the conversion of them to chemicals in the brain and retained as long-term information. And then there's what happens when we retrieve it, from that long-term memory and turn it into behavior. So, for example, the Williams sisters and Tiger Woods are both better adapted to their sports because they started playing them so young. So there's a process in the body where their body is trained and they have a physical memory and, physical patterns of how they move. But there's also that process of memory, and the amygdala and the hippocampus and the thalamus and the cortex, all the parts of the brain, sorting and storing and processing and connecting those ideas to themselves and actually making them better sports people. Tiger Woods has a golf primed brain because it developed while he was so young. He's actually changed the neurons in his head. So this development of memory goes on throughout our lives. Our peak is at about age 25. But each layer, we get more and more complex kinds of memory and more interconnected until we start to get memory decline, when the general decline in brain function and the hippocampus actually starts to reduce the amount that we can remember and work with. I find it really interesting that there's infantile amnesia, which kind of matches that cognitive developmental delay that we see in most mammals, particularly in humans, where even though they're born ready to live, they don't actually have the experience necessary to survive without that modeling, that observational learning from a parent figure. So there are a lot of theories of personality, and people came up with methods of studying personality. That we have traits that are genetic, we have characteristic adaptations that are developmental, and we have an autobiographical sort of memory narrative that we build out of our experiences, which aren't the same as adaptations based on our development. It's a really interesting interplay of those three factors into a person. I think the really interesting study, of course, too, is the psychodynamic versus the behavioural, the clinicians versus the scientists. They both really decided, they were quite deterministic. They decided that all behaviours have a cause and that free will is based on your past experiences, and that your early childhood is the stage when you lay down those behaviours and those past experiences that lead to patterns of behaviour. So we see different approaches to it. One is much more emotional, and it talks about the subconscious with Freud and being able to modify through therapeutic talk and surfacing unconscious conflict, whereas the other one is modified through experience and training, and that's Adler and his suicidal children, which I think is not sufficient. It's not sufficient to deal with humans. It's sufficient to think about animals, maybe, but I prefer that clinical approach where your brain and your psychology is dynamic and changing, and it's not set at 6 years old the way Freud says it was. He did get some things right, and he certainly made the move to psychoanalytic approaches really valuable. The ego, the superego, the id, that idea of the lizard brain that desires things, and the ego that controls it and manages it and makes decisions, and the superego that is a morality that is built out of your childhood and the way you were raised and the values you were taught, but isn't necessarily conscious. I think that is a really interesting ideal of how the brain works, and the idea of there being inner conflicts and inner defensive mechanisms that are all to do with moving the memories and collating them, and what you do with those negative and positive emotions and responses. But while I agree that unresolved conflict certainly affects our behavior, I think the later people like Funder and Maslow and Erickson had a much more sophisticated understanding of childhood development and its role in laying down patterns of psychology. Thanks.